Determine the domain and range of the function. Use the graph to help you. So here's the graph that I sketched. And I know this lesson is focusing on graphing by hand, so it's good if you're practicing along and creating your own graphs on your own paper. There's nothing wrong with double checking your graph on a calculator, but try to focus your work on the graphing by hand. So let's look at the domain. So I'm looking for values that are undefined in the function. And it looks like we have vertical asymptotes at x equals -1 and 1. So that means x cannot equal -1 or 1, just in simple terms. But now we want to write that in some type of notation. I'm going to use interval notation this time. So here's how we write that x cannot be equal to -1 or 1. We write what it can be. So approaching from the left side, we approach -1. And then we're going to combine that with the interval from -1 to 1, and also the interval from 1 and then increasing forever. So we're going to do a union, which is this U shape, -1, comma 1, union with 1, and then comma, and then infinity to show it keeps going forever to the right. So let me show you what this says. Open interval, -infinity, -1. That means all these x values to the left of the vertical asymptote here at x equals -1. There's a union with that subset with the open interval -1 to 1. That means all the values between -1 and 1, in between these two vertical asymptotes here. And then a union with all the values to the right, which is the open interval 1, comma, infinity. Okay, so here are these three subsets of real numbers, and the union of those together makes the domain of the function. Now, how about the range? Well, looking at the left and right parts, they both continue down, but then they both approach 0 on the y. And then this middle part looks like the low point here is at 2, and then it increases when you go left or right from there. So how do you say all that? Well, for the range, there are going to be two pieces to the interval here. First interval is open interval, -infinity to 0. That means that's these two branches here, the left and right branch, that go negative forever, and then they approach 0 but don't reach. That's why it's open. And we'll do a union of that with this other interval here, which is closed at 2, which means you include 2, and then continues forever upward, which it does on both sides. Okay, so let me review the process again. Looking at the domain, I found any vertical asymptotes because those x values or inputs are undefined, and that showed me that there were three subsets of real numbers, and we did the union of those three subsets to make the entire domain of the function. And then for the range, found this little gap here, y values that aren't defined for the function. And we did two subsets for that one, anything below 0 or negative, and then anything from 2 and greater. That's this closed at 2 and then open infinity. Okay, so that's how you can find the domain and range of a rational function. And good idea to use the graph to help you.